Okay, so g of x is this integral, right? So geometrically we know the meaning of this g is actually the area of the shaded region, right? The shaded region is bounded by the curve y equals f of t, y equals 0, x equals a, and x equals x, okay? F of t dt, okay, here just now we checked the textbook. D of t means what? The independent variable for this integral is what? T, okay, is t. And then what are the two limits for this integral? Lower limit is what? A. Upper limit is what? X.
And x may freely vary between a and b.
Yes. Okay, so just now you have read about it, okay? F is continuous on this interval. X varies between a and b, okay? So if x is a fixed number, say for example, x equals a constant c, c is in between a and b. If x is a fixed number, this integral become what? A definite integral, right? So that means this x is a given number. Can we complete the area of this region? Yes, we are. So this result is not a function of x anymore. It's a fixed number. Okay? Well, here in this integral, x varies. We do know x is what. So eventually this result, okay, the integral, this result, is not a number. It is going to be what? A function of x. So that's why we use another function g to denote this result. It is a function of what? X. Depends on x is what? We don't know. But x varies between what? A and b. You guys? Sounds good? Okay. See? If f happens to be a positive function, then g of x can be integrated as area under the graphs of f from a to x, where x can vary from a to b. Okay, yeah, think of the g as area so far function. Okay, so yeah, so this is the meaning for g of x. Okay, g of x. Okay.
Question.
Sure.
Can you give me the attendance?
Oh, yeah. How about after this video is over? Because if I go to the Ivy Learn, please remind me, okay? This will get interrupted, but remind me, okay? Once this part is over, okay?
Yes, ma'am.
You guys remember me, okay? Okay, so it says, okay, just now we talk about, okay, what is g of x, which is, geometric meaning, you know that, okay? And g of x is a function of x, depends on the upper limit x, okay? Well, the conclusion is, the derivative of g equals what? F of x. Okay, this is a conclusion. It says, if g is defined by an integral of f, then the derivative of g will equals what? F of x. Okay, so let's see what does g prime of x equals f of x mean? Okay, so g of x equals what? A to x f of t dt, right? So just this is g of x, okay? What is the derivative of g?
F of x.
Derivative g actually is an integral's derivative, right? Yeah, prime. Prime means derivative, right? Prime means derivative, okay? So we say this equals what? F of x, okay? So actually the key idea from this part 1 of the fundamental theorem is what? When we have an original function f, and then we integrate this function from a to x, and then we differentiate it, eventually what do we have? We have this function f back. Do you see that? From this f, we integrate first, then we differentiate it. Eventually we get f back. So that means integral and derivative or differentiation is a pair of what? Opposite or reverse or inverse actions, right?
Does the same also hold true that if you differentiate and then take the... Okay.
Yeah, that's going to be a second part of the fundamental theorem, right? Okay, you got it. Okay, very good, okay? So the part 1 of the fundamental theorem is telling us, what is the relationship between differentiation and integration? Now we know. Differentiation and integration is a pair of what?
Inverse functions.
Yeah, not inverse function, but it's a pair of reverse actions, okay? So we integrate first, then we differentiate it. Oh, we get this function back, okay? All right, so now let's look at some practice questions, okay? All right. our g of x is defined from 0 to x f of t dt, where f is a function whose graph is shown below. Okay, what is a graph of f? Okay, f, the function of f is shown. Okay, f is shown here. Okay, yeah, so this is t. Okay, this is t. This is the graph of f of t, okay, y equals f of t, okay? Okay. Alright, our g of x is defined by what? The integral from 0 to x f of t dt. Okay, we understand that. What is geometric meaning for g? It is area for that what? Region S, which is bounded by the function below the function, between the function f and then y equals 0, and bounded by the x equals 0 and x equals x, right? Grant?
I thought that for us to work with these sorts of shapes, they had to be differentiable, but that's full of sharp lines. I thought you couldn't differentiate. I thought you could only differentiate if it was continuous.
Yeah, well, f is confunction whose graph is shown. So f is differentiable on here, right?
Yeah. It's differentiable on many of those individual segments, but across most of it, you hit some kind of kink, which isn't differentiable.
Yeah. It says f is continuous. It doesn't say f is differentiable on the closed interval a to b, right?
I thought it said that on the paragraph above it. I must have been mistaken.
F is continuous. Continuous means as long as we draw the picture without lifting the pen, it is continuous, but it doesn't say f is differentiable. So you're
It says differentiable on a to b. The very end of the sentence. On the open interval a to b.
It says that g is differentiable on a to b. It doesn't say f is differentiable, right? So for function f, as long as it's continuous, that means it could not be differentiable on those certain points, right? But f is continuous. And then g is what? G will be differentiable, continuous, and differentiable on a to b. Then we differentiate g. We're not differentiating f.
Sorry, silly question.
Yeah, very good. I think your question is very good. Alright, so from this graph, or this is graph for f, we can tell that is f continuous or no? Yes, it is continuous, right? Because there's no folds, no jumps, nothing, right? It may not be differentiable, but it's continuous, right? From when t equals 0 to t equals what? 7, right? To 7. So let's count. 1, 2, 3. This is 4. This is 5, and 6, and 7, right? 7. Alright, so let's evaluate this g of 0, g of 1, g of 2, g of 3, and g of 6. Give it a try, please. What does g of 0 mean? Means this x has to be replaced by what? 0. So we should have a 0 to 0 f of t dt. It is going to be what?
0.
0. Remember, right?
No area.
Yeah, no area or a to a. Remember we learned that property, right? So it's a 0. How about g of 1? 0 to 1 f of t dt, or geometrically it is going to be the area of the shaded region, right? So what is the area for this rectangle? Yeah, 1 times 2, 2. Okay. Now let's check g of 2. Well, g of 2, actually, if we write it down, 0 to 2 f of t dt, right? Remember the property we learned for the integral, okay? From 0 to 2, the integral we can define it to be what? From 0 to 1 f of t dt plus what? 1 to 2 f of t dt. Remember this, right? So what is from this integral from 0 to 1? It is g of 1, right? So we don't have to compute. Okay, so this is g of 1 plus what? 1 to 2 f of t dt. So g of 1, we know it equals what? 2, which is what? The area for this rectangle, right? Which is 2. What is integral of f of t dt from 1 to 2? The area of this region, right? So how do you compute this area? can we cut it into a triangle and then a rectangle? Yes or no? Wait,
Sorry.
go
Well,
ahead.
the triangle on top, which is half of an area
Yeah.
too, so it'll be 1.
Yeah, so this is 1, and this is 2, right? So eventually that's in total 3, right? So give us a 5, right? So G of 2 equals 5, right?
Wait. Oh, yes, sorry.
Yes? 1 times 2, 2 divided by 2, right? The area for triangle we have to divide by 2, right? And then this area is 2, 2 plus 1 is 3. 3 plus this 2 gives us the 5, right? So this is G of 2. You guys, everybody clear? How about G of 3? We already know the G of 2, right? We only need to add up from 2 to 3 f of t dt, right? So what is G of 2? 5. 2 to 3 of t dt, which is what? This shaded region, right? Right? Okay, so how to compute this region? Area of the region.
The base is 1.
1, height is 4, right? 1 times 4 is...
The triangle perfectly cuts that region in half, so you can take half of it.
Yes. So 1 times 4 divided by 2 give us the 2, right? So G of 3 equals what? 7. 7? Yes, right? Okay.
Oh, I see. So that's why they say area so far, because it's creeping from left to right. Okay.
G of 6. We know the first 3, right? When t was, the first 3, right? So G of 3 plus what? From 3 to 6 f of t dt. We have to be very careful here. When t is less than or equals 3, or between 0 to 3, our graph is above the t-axis. Now since when t is greater than 3, all of this entire region, it is what? Below what? It is below the t-axis. Careful here. We only need to count. Let's count. This is 4, 5, and 6. We need the area below the t-axis from when t equals 3 to what? 6. What is the shape of this region? What is the shape of this region? It's a trapezoid, right? Either we consider this is a trapezoid, or we can consider this is what? It's a triangle plus what? A rectangle. Guys, do you see that? Okay. So G of 3 we know it is equal what? 7. Also be careful here. Okay, be careful. If the region is below t-axis, how about the area? It becomes negative. Yeah. So this is positive. This will become what? Negative. Okay. So what is the area for this trapezoid in total? Okay, so let's look at this triangle, right? Triangle. So it has a base 2 and height 2, right? So base 2 times height 2 divided by what? 2. That's the area for this triangle, right? Also, what is area for this rectangle? 2, right? So we add up the sum of the triangle and what? Rectangle. 7 minus 2 plus 2 is what? 4. So eventually, G of 6 is what? 3. You guys, that was good? Alright, now these are the evaluations, okay? Now question B, at what intervals is G increasing? And number C, where does G have a maximum value?
0 to 3 and 3.
Yeah, see? When t varies when x varies, okay, because g is function of x, okay? When x varies between 0 to 3, the g value keeps on what? Increasing, okay? However, when x is greater than 3, our f function is below the t-axis. We will have to keep on to minus the area, right? So, on which interval is g increased? I will say from 0 to what? 0 to 3. The 0 to 3 is for x. Okay, x varies between 0 to 3. Where does G have a maximum value? Where? Yeah, so g of 3 is what? Equals 7 is our maximum value. You guys do see that? Can you see this, right? And sketch a rough graph of g, okay, above g, okay? So I'm gonna draw a picture here. Okay, so now for g function, what is horizontal axis? What is the variable for the horizontal axis? Is it t or x? X, okay? G is a function of x, okay? And then this is what? This is g, okay? This is g, okay? All right, and then 1, 2, 3, 4, 5, and 6. We only compute g of 6, right? Compute g of 6. So when x equals 0, g equals what? 0. When x equals 1, g equals what? 2, right? 1, 2, 3, 4, 5, and 6. Okay, so g of 0 is 0, g of 1 is 2. What is g of 3? G of 2, sorry. G of 2 is what? 5, right? 5. What is g of 3? 7. Okay, and then g of 6 is what? 3, right? Down to 3. So briefly, can we draw a picture for the g? It may not be a straight line, it's just a briefly graph, okay? You can briefly, because depends on this, okay? You know, the g may decrease more or less, okay? So briefly, g increase when x is between 0 to 3, and then keeps on to decreasing when x is greater than 3. You guys? So that's good for this question, everybody? And then the most important thing is we know what? The derivative of this integral from a to x has to be the upper limit, equals what? F of x. Okay? Alright, so now let's use this conclusion to look at our practice question on the next page. Examples. Use a part of the fundamental theorem of calculus to find the derivative of the function, okay? G of x equals 1 to x ln of 1 plus t squared dt. What is the derivative of the function g?
ln 1 plus t squared dt?
Yes. G prime of x equals f of x. What is f? This is f of t, right? Right? If g of x is defined by a to x f of t dt, g prime of x will equals what? F of x, right? So we only need to find out what is f, right? And then eventually it is ln 1 plus what? X squared. Done. Question 2. If capital F of x is defined by from x to 0, square root of 1 plus secant of t dt, how to differentiate capital F? Can we use our fundamental theorem part 1 directly? What is f of t? This is easy to find, right? This is f of t. But is this integral given by from a to x? No, but we have to make it to be, a to x. So how? Remember? If we interchange the position of these two limits, we have to put a negative sign, right? So negative 0 to x square root of 1 plus secant t dt. Right? Now can we differentiate? Yes, we are. The derivative of capital F of x will equals what? F of x negative f of x, right? So negative square root of what? 1 plus secant of x. Done. You know why this? Where does this negative sign come from, right? Because the given integral is not from 0 to x. is from x to 0. So we have to make sure that the lower limit is a constant. So that's why we have to rewrite it as negative from 0 to x. Then we differentiate that, give us the square root of 1 plus secant of x. And then we have a negative sign. So that's good for the first part of the fundamental theorem, Grant?
I was just saying, all good.
Okay, you're good. Okay. All right, now let's look at the second part of the fundamental theorem, okay? All right, I'm going to ask another volunteer to read this part for us. Who want to read? Simon? Oh, no. Tyler?
If f is continuous on AB, then integral f of x dx equals f of b minus f of a, where f is any antiderivative of f that is a function such that f prime equals f.
Okay, very good. Okay, very good. All right. F is continuous on A to B, right? No differentiable, okay? It's continuous, okay? Then the integral of what? F of x, okay, well dx from A to B, okay, equals what? Equals capital F of B minus capital F of A. This is a definition for definite integral, right? Remember we learned this, right? Did we? Have we? Or not? If not, that's fine, okay? So here, when we integrate f of x, okay, we should have what? The antiderivative of lowercase f, right? So capital F is the antiderivative of f, right? Okay, remember we learned that what is the integral of f of x dx, it equals what? Capital F of x, right? This capital F is the antiderivative of f, right? And plus what? A constant c. This is called a what? Indefinite integral, right? And then if we have limits from a to b, okay, then this integral is called what? Definite integral, okay? Okay, so we have to learn this. This is part of the conclusion from part 2, okay? Well, the most important thing is, okay, because f is an antiderivative of f. That means what? When we differentiate the capital F, we'll have what? F, right? So, how can we understand this part 2? Remember from part 1, what do? We integrate first, then we'll differentiate, right? Well, this one is what? We differentiate first, then we integrate. We will get the original function capital F back, okay? Well, here it says, okay, because f prime equals f, because capital F is what? Antiderivative. So it satisfies capital F squared derivative equals f. Well, here we're going to replace this capital lowercase f by what? Capital F prime. So this we can rewrite it as what? Integral from a to b, capital F prime f of x dx equals what? F of b minus what? F of a. Guys, what do you see from this? From here, if we have original function f, we differentiate first, then we integrate from a to b. Eventually we'll get what? The original function f, capital F, back. Okay? However, because this is a definite integral, we have to evaluate the capital F at b and then subtract the capital F at what? A. Okay? See, integrate first. This is differentiate first, then integral. Then we get the original function back. Previously, part 1, what did we do? We integrate first, then we differentiate. We get the original function lowercase f back. Do you see that? Okay. Alright, now the second part of the fundamental theorem also is very important because it tells us how to evaluate definite integral. Okay? To find an indefinite integral, what do we do? Remember? If there's no limits, this is called an indefinite integral. How do we do the integral? We only need to find what? What is antiderivative of lowercase f, right? So we put the capital F there, and then we plus a c as a family for as a family results, right? It's a family of functions as a result for indefinite integral. For definite integral, as long as we have limits, what should we do? Once we found the antiderivative of lowercase f, which is capital F, we have to evaluate the capital F at the upper limits first, then subtract by f, evaluate at what? Lower limit, secondly. Okay, so I will show you, okay, there are 4 questions. I'm going to show you 2 problems, okay, and then I'll let you try the rest by yourself, okay. So let's try question B and question D, okay, C and D. So, evaluate this integral, okay, from 1 to 4. If the integrand, okay, yeah, this function, we call it this integrand, is defined by 2 plus x squared over square root of x dx. How to find this definitive integral? Do we have any formulas that give us the antiderivative of 2 plus x squared over square root of x? Do we have any? No. But can we split this integrand, this function, by 2 over square root of x give us what? I don't want to skip step, okay? Because if I skip step, you guys will not follow. How about this? Split it into 2 terms, right? 1 to 4, 2 divided by square root of x, x negative 1/2. Do you agree with this? Because 1 over square root of x equals 1 over x to the 1/2, right? 1 over x to the 1/2 gives us x negative 1/2. Okay? And then x squared over square root of x, this is x to the 3/2, right? Plus x to the 3/2 dx. What do we do from here? We want to integrate, right? So we need to find what? Antiderivative. What is antiderivative for x to something, x to something? Remember? X to the nth power dx. What is the formula for antiderivative? 1 over what? If the power of x is n, y equals 1 over 1 plus n times by x to the what? 1 plus n's power. For indefinite integral, we have to add a constant c. Right? Okay, here, what is n in this term? Negative 1/2, right? So, 2 is due to 1 over 1 plus n times x to the 1 plus n. This is a antiderivative from the first term, right? And plus 1 over 1 plus n x to the 1 plus n. This is a capital F, right? This is an antiderivative for this given function, right? However, we have to evaluate from what? 1 to 4. Okay, so this is a vertical line, okay? This is a vertical line from 1 to 4. Okay, we write it this way means eventually later we're going to evaluate this capital F of 4 and then subtract the evaluation of this function of what? Of 1. Okay, now let's simplify. What is 1 minus 1/2? 1/2. 1 over 1/2. 2. 2 times 2. 4. Right? What is x to the 1 minus 1/2? X to the 1/2, which is what? Square root of x, where you say x to the 1/2. Plus what? 1 plus 3/2. 5/2, right? So that's 2/5. X to the what? 5 over 2, right? And evaluate this from where? From 1 to 4. Okay, so let's do evaluation, okay? Plug in x by 4. 4 times square root of 4 plus 2/5. This is 4 to the, this is a 5th root of x squared, right? 4 squared. This is capital F of 4. Minus, plug in every x by 1. 1 plus 2/5. 1 to the what? 5/2. And let's see what this gives us. Square root of 4 is what? 2, right? 2 times 4, 8. 2/5. 5th root of what? 16. There's no way we can get rid of the 16, okay? Because 16 is 2 to the 4th power. And then this index is 5. So 16 is kept under, okay? And then minus what? Minus 4 minus what? What is 1 to the 5 over 2's power? 1, right? You go with me, everybody? So let's see what we can have here. A minus 4 is what? 4, right? 4 minus 2/5 give us what? 20 over 5, 2 over 5. This is 18 over 5, right? Plus what? 2/5 times by 5th root of what? 16. This result looks odd, but see, we're using this, okay, we're using this. This is so important. You will see not just in Calc 1, in Calc 2 we use this again and again. This is how to compute a definite integral, okay? Yeah, find any derivative of lowercase f, which is capital F, evaluate at the upper limit, subtract by evaluate at the lower limits. So that's good for this question B, everyone? Can we move on to another question? Another question is here, the number D. It's a trig question. So that's why I want you to read you, okay? And the other two questions that you can try, okay? You can try. So let's look at this question. Lower limit is pi over 6, upper limit is pi halves. Cosecant t times by cotangent t dt. Oof. So complicated. What is cosecant t? Do you remember? Still remember? We can rewrite cosecant t as what? Pi halves, pi over 6. What's the relationship between cosecant t and cosine or sine? Secant t equals 1 over what? Cosine, right? How about cosecant then? 1 over sine. Do you go with this? Okay, so 1 over sine of t. What is cotangent t? Cotangent t can be written by cosine divided by what? Sine, right? So actually, pi halves, pi over 6. On the bottom, we should have a what? Sine t square. On the top, we should have what? Cosine t dt. Well, this is actually questions beyond our knowledge in this section because we might have to use the substitution rule. Okay, substitution rule will be taught in section 5.5. We will not cover it in Calc 1, but we'll do it in Calc 2. Okay. All right. So, how to integrate this thing? How to find any derivative for this? Cosine t dt. Okay. Yeah, this is hard, okay? Pi halves, pi over 6, 1 over sine of t squared. I say cosine t dt can be written by what? d of sine of t. Why? Differentiate sine of t with respect to t by chain rule, it should be what? What is the derivative of sine? Cosine. And then times by what? dt, right? So cosine t dt together can be written by d of what? sin of t. Guys, do you see that? And now you see, the variable is not t anymore, it becomes sin of t. And then this is a function of what? Sin of t. So we only need to find what is the antiderivative for what? 1 over sin of t squared. Okay, so what is 1 over sin of t squared? Pi half, pi over 6. I would say this t of negative 2's power. Agree with me? 1 over sin of t squared can be written by what? Sin of negative 2, right? Okay, dt. D of sin of t. So, assume this is x. Assume this is x. What is antiderivative for x to the negative 2's power? What is antiderivative for x to the negative 2? 1 over 1 plus n, x to the 1 plus n plus the constant c, right? So that gives us the 1 minus negative 1, 1 over negative 1, negative x to the what? Negative 1 plus constant c. So here this x is our sin of t, right? Guys, can you follow me? This is hard, okay? So we should have a negative. This is what? This is actually negative 1 over x, right? Plus c. So x is sin of t, right? So negative 1 over sin of t. This is a capital F, okay? This whole thing is capital F. We're going to evaluate from what? Pi over 6 to pi halves. Okay, this is capital F. Okay, so now we only need to evaluate, and we write it here, okay? Negative 1 over sin of what? Pi halves, right? Okay, minus what? Negative 1 over sin of what? Pi over 6, right? Replace t by pi over 6. Replace t by pi halves. So this gives us negative 1 over, what is sin of pi half? Sin of 90 degree, what is it? 1, nice? Yes. Minus negative become positive. 1 over, what is sin of pi 6? Pi over 6. Sin of 30 degree. What is sin of 30 degree? 1/2, right? So we're having negative 1 plus 1 over 1/2 is what? 2. So eventually answer is what? 1. This is hard, right? This is very hard, okay? However, the question I want you to practice is not as hard as this, okay? What's up?
Does it ever annoy you when a big ugly function like that boils down to something really simple?